Well, hello, everybody. Welcome back to another Virtual Connect from AI Colorado. Today, we've got another edition of a very popular session that we've done before at our Practice and Design Conference from an expert that we all know and appreciate from the Rocky Mountain Institute. Today, you get 1 HSW credit for attending today's session. So we would like you to stick around until the end to make sure you get that full credit. We also will have time for questions, so you'll have a lot to digest, and I'm sure you'll have some inquiries along the way. So we ask you to use the Q&A function throughout today's presentation. As soon as you have a question, just write it in there in the Q&A and we will get to it as we progress through the time together. Now, more about our presenter. Victor Olgyay, AIA, is a bioclimatic architect and principal at Rocky Mountain Institute. In 1978, he designed his first passive solar house and has since worked as an architect, writer, researcher, daylighting designer, and environmental consultant. Was that a kindergarten project, Victor, back in 1978? Since 2005, he's been a principal with Rocky Mountain Institute, leading the Institute's buildings practice to encourage widespread adoption of net zero district developments, low embodied carbon materials, and comprehensive building energy retrofits. From 1993 to 2000, Victor was an associate professor and director of research at the University of Hawaii School of Architecture. He was appointed chairman of the AI Honolulu Energy and Environment Committee in 1995 and served there until 2000. In 1998, he was named a Dana Fellow of the Joslyn Castle Institute for Sustainable Communities. He served on the board of directors for the American Solar Energy Society and is currently on the University of Colorado Design Review Board and the General Service Administration Green Building Advisory Committee. So Victor, we're grateful for you to be here today and to tell us more about zero energy districts and how they fit in with our plan for a more climate positive and resilient future. Without further ado, thank you and take it away.
Well, thanks, Mike. Let me see if I can get my slides up here. Okay. Is that visible?
Looks good, perfect.
Great. Well, thanks for having me here. I really appreciate everything that the AIA does, and I have been a member for a long time and benefited a lot from the AIA and always glad to give back. I encourage everybody else who's on the webinar also to consider participating in your local chapter and assisting with the development of the profession. But really what I'm here to talk about today is a lot of the work that we're doing with our Rocky Mountain Institute, where I'm a principal and work in the buildings practice. We are really focused on climate change. And as you probably know, buildings, of course, are a big contributor to climate change. But the good news is that buildings are also a big part of the solution. And what's really interesting, I think, over the last 10 years or so is that we've recognized that we now have a lot of data and examples of buildings which show we can skillfully and profitably address climate issues with our architectural design. So that's what I'd like to do today, is talk about how you as architects and designers can actually have a positive impact on climate change. So I'm expecting that most of you right now are looking out a window of some sort. And question is, if you're inside a building looking out a window, what do you see out there? Do you see another duck? Do you see another building? Do you see a cat, tree? And I know right now, during these times of COVID, you might feel sort of disconnected from a lot of what's going on in the outside world, but we still really rely on all those things that are going on out there, the trees producing oxygen, absorbing CO2, all the transportation going by and bringing us goods and services. But what about those buildings out there? How connected are we to those? You know, we don't really share that much with these buildings across the street, but we really depend on a lot of those same services, and we have a lot of the same sort of needs and concerns. You might recognize this sort of mid-century modern house by Ray and Charles Eames. And to me, this is sort of emblematic of what we kind of started thinking about in terms of architecture and connections. And in the sort of mid-century modern time, people started making connections to comfort, the indoor-outdoor connection, of course, the connections between the making of architecture and industry, and understanding what kind of the meaning of those connections were, both positively and negatively. There's a really interesting quote by Ray Eames, I believe, who said, "We wanted a more efficient technology, and we got pesticides in the soil. We wanted cars and television sets and appliances, and each of us thought that they were the only one wanting that. And our dreams have come true at the expense of Lake Michigan. That doesn't mean that the dreams were all wrong. It means that there was an error somewhere on the wish, and we have to fix it." So there's a sense here that we need to understand these connections in a systematic way, and we can actually improve the quality of life through improving the quality of these connections. Everything connects, and a lot of what we'll be talking to today is trying to understand how we can take advantage of some of those connections. Buildings have started to really be positively influenced by nature. We see lots of exciting architecture coming that is formally influenced, that has higher performance, that basically is, you know, a kind of an evolution from, in some sense, from this mid-century modernism, when we're understanding how we can actually take advantage of those connections. But, you know, that's not all, really. And individual buildings still can have issues. This is actually the building where my office is. I haven't been in there for a few months, but Boulder Commons, it's about 100,000 square foot office, and it's a net zero energy building here in Boulder, Colorado. And you'd think, oh, it's a net zero energy building. That's great, and it is. But it also can have negative impacts, and I'd like to talk about that a little bit. So here is a curious animal. This red line here is called a duck curve. And this red line shows how electricity demand changes over the course of a day. And this is kind of a California summer day, you could say. And this red line is supposed to be kind of similar to this profile of the duck. You have to use your imagination a little bit. But essentially what happens is, you know, there's some load in the morning, and then as the sun comes up and there's a lot of solar energy that comes onto the grid through photovoltaic collectors, the net load goes down. And then over the course of the day in the evening, as the sun goes down and there's less solar energy on the grid, the utility has to kind of ramp up its power. And then of course that goes down again. So the blue line shows the total load, and the red line is the net load. And it's kind of wavy, right? And so this actually ends up being really difficult for utilities, this up and down of the load. And when you ramp up like that, and you have to, the utility company needs to, you know, bring more plants online that might be on the margins, it ends up being more expensive. It creates, you know, high demand, and it's expensive electricity, and it oftentimes is more polluting. Not always, but often. So in contrast, what we can do is we can kind of try and take that bird to flight. So we can take that bird and even out the loads. So we can have our buildings sort of even out the loads by shifting some of them, lowering the overall loads, but also shifting them so we don't get these troughs and peaks as much. And with this kind of use of different techniques to kind of even out some of the building loads, we can have cost benefits, energy benefits, pollution benefits, resilient benefits. Overall, it's a big opportunity for us to balance our building demand to follow supply. So it's kind of operating your building effectively to, ensure that you're not causing more problems. So this top line is the one, this red line is really sometimes what we see as an issue with net zero energy buildings. And what we're saying is that those buildings need to be a little bit more aware of their connections to the larger utility grid. So here's another way of looking at this concept. And when we start to connect to the utility grid, we sometimes call these grid interactive efficient buildings, or GEBs. And what GEBs do is they kind of work as have buildings work as an extension of the utility, as an asset to the grid. And so it's a bunch of different things that we can do in order to kind of have our buildings work better. And these little graphs at the bottom show a typical building, one which lowers the curve with this yellow line through building efficiency. And then when we add solar PV, we get this duck curve, which now is like a, I don't know, so what kind of animal that is, not quite a duck, but the same idea of a steep trough and a steep increase in loads. And then if we actually think about shifting those loads and start to think about how we can use storage and other things, we can even those out more. So we can get this idealized kind of dark brown line, which is indicating kind of a reduced impact on the grid as well as in your building. So we can really optimize the way that buildings interact with the grid. So this might seem just kind of like a nice thing, like, yeah, let's be nice to the grid. But it really can have huge impacts in terms of our funding. We did a study for the GSA, the General Services Administration, the nation's largest landlord. And we showed that there could be around $100 million in annual cost savings, basically about a third of the GSA's annual energy spend, with less than a 4-year payback, just by kind of taking some of these grid interactivity things into account. And that's because so much of our energy costs are about demand charges. They're not just the consumption of electricity, but it's consumption of electricity at these peak times when it's more expensive. So it really benefits the customer, but it also really benefits the utility. And we also analyzed that and thought that there was probably around $150 million per year in value to the grid in terms of reduced capacity and transmission costs and things like that. So there's resiliency benefits, there's benefits in terms of reduced carbon costs. There's just a lot of quantitative measures as well as kind of just general benefits. So let's kind of take a look at this quickly. It can be a source of income. It can help the grid run more smoothly and provide all kinds of different services to the grid. Things even like frequency regulation, spinning reserves, but really that demand flexibility and storage piece is the key right now in terms of costs and being able to kind of make money off of it. And then in addition, it can also sort of help with the reduction of carbonization of the grid. And these grid services are just one part of the overall architecture. And I think a lot of times people think of, solar buildings or green buildings as, sort of a separate type of animal, as it were. But really, the key is going back to kind of the Ray and Charles Eames thing of integration, right? It should be part of this synthetic way of looking at things. And that's the way the most benefits happen, both to the occupants, the different stakeholders, and also to the architecture itself. So take that integrated design approach. So this is really interesting in terms of emissions because the demand may or may not coincide with the emissions on the grid. And this chart shows that the emissions on the grid varies quite a bit. And some places it varies more than others, but this is showing on the vertical axis the hours of the day, and the horizontal axis, the x-axis, is the months of the year. And the red areas are the highest emissions. And in this case, in SMUD in California, Sacramento region, you see summer peaks, afternoons, that's when the grid is the worst. And it's kind of that cooler time, both in the shoulder season, spring and fall during the day, as well as just cooler times of day, that the emissions tend to be lower. So we can actually operate our buildings in a way that by when you purchase the electricity, you actually are purchasing lower carbon electricity, and you can influence the amount of carbon on the electrical grid. This comes from watt time, but there are other players as well in this field. And it's a really interesting thing to try and coordinate the emissions along with the demand side. So the cost and emissions don't always coincide, but you can get 80, 90% correlation and really optimize for both of those concerns. So how does this apply to us? Well, we can actually take individual buildings and put them together into communities, as is obvious, and then try to optimize the performance of those communities. So how do we talk about these connected communities? Well, grid interactive and efficient, so they can kind of modulate their energy use. They connect with these other grid services. So not only do they do it, but they actually work with utility, have different kinds of distributed renewable energy generation and storage and so forth. And then they are optimized over the group of buildings. So it's not just 20 buildings, each one individually kind of working, but it's building A and B working with building C and D in order to optimize across those smaller kind of set of buildings to even further get benefits in terms of flexibility and renewable energy generation. Sometimes they employ shared systems, especially kind of thermal plants or energy storage. And that often helps if it's a geographically contiguous system, but it can also happen through a portfolio of distributed buildings as well. And then finally, the issue of having sort of smartness or intelligence and data connecting these buildings is critical. And this is starting to become an area where we see a lot of development, and with these different control platforms that enable this multi-building grid interactivity and optimization. So not all connected communities have all of these things, but most of them have a few of them. And we're going to take a look at a few of them. So I've got 9 case studies that I'm going to go through. Some of them are really short, some of them are a little bit more detailed, but they all kind of talk to different aspects. We'll talk about connecting to site resources, to grid services, connecting buildings to refurbishment cycles over time, so when to actually do renovations, connecting to mobility, and then centralized resources with Hazelwood Green. So the first 3 are kind of residential. And you might know of this project, which is here in Colorado, Fort Collins. It's a nice little residential project, pretty much completed. And it's a new development, market rate, and net zero energy. So they basically have highly efficient buildings with solar PV, as well as with ground source heat pumps. The site plan is pretty dense. It's a mixture of single family houses with row houses and multifamily buildings. It's got pretty good performance. They, I think, are typically a negative HERS rating. So those of you who know about the home energy rating system, most codes require you to get, a certain a certain level of efficiency based on a HERS rating, depending on the size of your house or so forth. These are negatives, which means they're actually producing more energy than they use over the course of a year. This is actual data from a couple of years ago. And you can see it's using a little bit of energy in the wintertime, but basically the rest of the year it's producing more energy than it's using. So I think it's a negative HERS rating of about 8. Not huge, but definitely better than net zero. And then the economics actually work out well also. So with the increase of cost, that's required to get these buildings to net zero, increased insulation, better windows, air-to-air heat exchangers, things like that. There's some cost associated with that. And that got rolled into the mortgage payment and with solar and some other things. And the increase in the mortgage payment is actually less than the overall amount of energy savings over the course of a year or a month. And I think this is kind of a critical point, is that a lot of times we look at costs either on a first cost basis or on a very short-term basis or isolated from the other benefits. And I think a lot of times we can make all of these high-performance buildings very cost-effective by looking at it in a more integrated approach. And I think as architects, that's sort of our strength, not necessarily the engineering side of it, but just the idea of starting to understand how we can make these connections across different disciplines in order to make things pencil out. Take another look at an existing community here. This is this is Ecobloc in Oakland, California. And it has not been built, but it's a really interesting study of taking typical blocks in California and adding distributed solar PV with some centralized resources, in this case, energy storage. Similarly with water, there's a kind of a ganging of the water systems, rainwater catchment, and also with the wastewater. And then these all get kind of folded together into a community where you've, you first off kind of reduce all of the loads through efficiency and insulation and electrification, but then you're also able to add in additional things like charging for electric vehicles and other kind of centralized energy storage and so forth. And so by doing this in this larger context, it can be done quite cost effectively. And again, I think what's critical here is this is being applied to existing communities in this case, where you have, since we have such a large number of existing communities, it's critical that we start to understand how we can apply a lot of these sort of smart, connected approaches to that infrastructure that we already have. Now, this last kind of residential community group, I think, is my favorite in the moment, which is up in Basalt here in Colorado. It's being built. They're super affordable. I believe Habitat for Humanity, there's many of them. And they're pretty straightforward. They're just really high efficient houses with heat recovery ventilators and cold climate heat pumps. They have PV on them, and they have battery storage, EV chargers, so forth, a lot of fairly standard stuff. The part that's really interesting is that they also are connected with a system, which I think Holy Cross is the utility up there, and Holy Cross is trying to get their electricity grid to be decarbonized as well. And this is part of it because they can kind of shift loads with these buildings because of the storage and because of these controls. And basically help balance their grid. Now it's a small amount, right? These are 30 units out of, I have no idea how many buildings they have in their system, but this is a way of starting to have these buildings be a positive, interactive grid asset to distributed energy resource, and it's able to kind of use these houses, this residential development, to harmonize with the larger grid. I think it's a really good example of what we can imagine coming more in the future. So I'm going to now start to talk about some of these other grid services. Here's two projects that are kind of in process. Pena Station is one that many of you probably know as you've driven to the airport. It's just this big kind of covered parking lot is pretty visible, and also is a great place to park if you're going away on the plane. And you can plug in your vehicle and it'll be charged when you get back. It's also got a large microgrid there, and it kind of is particularly interesting because the support through the batteries and the solar and the microgrid was enough that Xcel Energy, that's out there, was able to avoid the capital cost of building an electrical substation because of all of this other kind of grid infrastructure. So all of the kind of interesting bits that we've been talking about in terms of buildings as a kind of asset to the grid are manifest here quite explicitly. These are what those batteries look like. There's, I think, about a 1.5 megawatt PV system, 2 megawatt hour lithium ion batteries here that you're seeing. It basically is providing clean energy. As you know, they're building out a lot of the residential communities behind there. I think eventually it's probably about 400 acres and 100 buildings or so. And it's a transit-oriented development, which ends up being, of course, critical. It's nice that there's a light rail stop right there. Of course, if anybody was flying, you could fly from there. And you can get downtown very easily as well. So walkable and lots of good public services available. And transit is critical, making that connection. In Georgia Tech, there's this Georgia Tech Flex project, which is just going on now. DOE, NREL, and Rocky Mountain Institute are collaborating on this along with Georgia Power. And the idea is to take, again, 18 existing buildings and start to understand how we can optimize their energy use, both for benefit to the client, Georgia Tech, but also for benefit to Georgia Power, the utility. And so it's quite interesting. One of the things that's coming up as an important issue is that those buildings have diversity. So there's some buildings there like the Data building, which is a net zero living building challenge certified building, very high performance. And there are other residential buildings that are fairly typical dormitory type buildings. There's classrooms, labs, all kinds of stuff. And the diversity of loads actually helps us think a lot about how these things can get balanced out. We've gone through and we're now in the process of quantifying a lot of those benefits. So once those things are quantified through analysis with UrbanOp and Zendy and some other things, and we can sort of see how much pollution or costs are being saved, then we're expecting this to be implemented. Analysis should be done in the next few months, implementation hopefully by the end of the year. So we'll see. Keep your eye on Georgia Tech. Zero over time is, I think, again, an interesting way of thinking about existing communities and how can we make them part of the solution. So the idea here is that we have so many existing buildings, and how can we actually retrofit them most cost effectively? So one approach to this is to kind of look at buildings when there is actually a need for capital investment of some sort. So oftentimes when a lease turns over, you're going to go ahead and do some tenant fit out, or if it's sold, there's oftentimes changes that happen, or if there's some larger capital improvement that's necessary because of a system failing, and needs a new water heater, you need a new roof, whatever it is. Those are also times to start thinking about about efficiency and building that in. So if you plan for that, you can, as your building, ages and suddenly there's a new tenant that comes in, or there's a need for a major equipment replacement, and you've planned for that, then you don't replace that piece of equipment with the same thing, but maybe you actually are able to electrify your building at that time and go with a heat pump, or maybe you, at the time that you're doing the tenant fit out, you can actually go ahead and insulate walls or switch out for better windows. So all of these events, these different triggers, give you the opportunity to increase your efficiency over time to, at the end, actually getting to a net zero portfolio. And it's really interesting because obviously this is happening at different times to different buildings. So when you have a large number of buildings, this really adds up to both high energy savings and a lot of cost savings. So here at Arizona State University, they have these really ambitious goals, getting to climate neutrality by 2025. We worked on this project about 5 years ago, so they're well into it now. And they wanted to get to climate neutrality by 2035. So they took this approach of looking at zero over time and understanding, when that there was a building that would be a deep energy retrofit, when we're going to add, solar, when we're just basically going ahead and, doing some regular upgrades. And over time, we were able to show that this would be the most cost-effective way to do it. So this first bar shows kind of business as usual. The second is no net energy efficiency, just adding kind of renewable energy and as you move along. The third one is doing all of those things of efficiency and so forth, but not necessarily coordinating it with the end of life of our equipment or other kinds of kind of trigger events that allow for efficiency. So if we look at that kind of zero over time scenario, we found that that's actually the most cost-effective, more cost-effective than business as usual, and also gives you a positive ROI, net present value. So it's really makes a lot of sense. I mean, it's of course planning is typically a good thing, but especially when you've got a large campus like Arizona State University, and you're trying to kind of have these big goals of getting to climate neutrality, and you want to do it cost effectively, you can actually design your building infrastructure and maintenance to be coordinated with your climate goals in such a way that it actually benefits both of those. So it's a very nice way of doing it. Last thing I'd say about ASU is that they're doing most of this through a energy service provider model. And so what happens is the energy service provider has a guaranteed cost and return, and they are able to do, basically they have first right of refusal on these projects, and be it a renewable energy project or a building efficiency project, they can go in there and they can make money on it at the same time as ASU is benefiting as well by reduced costs and reduced pollution. We've also applied this to some work that we've been doing with the city of Pittsburgh. They also have fairly aggressive energy goals, in this case wanting to get their municipal buildings to zero carbon by the year 2030. So be it for better or worse, they have a big portfolio of, I don't know, 150 or so municipal buildings that are really not in a great state of repair. So they all do need to be invested in. And the question is, how much can they invest at what time? But what we tried to do is, again, coordinate that investment with efficiency improvements, and also require that they don't do it based on kind of lowest first cost. They really want to be able to do this based on a life cycle cost. So we ended up with a sort of a scenario that looks like this, which essentially this top slightly sloping line indicates if the business as usual case, right? That would be essentially, how much CO2 would be produced with marginal improvements in efficiency. You're switching out, lighting, or, when a rooftop unit fails, you're putting in kind of the typical model. So there'd be slight, slight improvements, but really not getting anywhere near what they needed to get to by 2030. This bottom sloping curved line, this is actually trying to coordinate efficiency improvements, and this is bringing the buildings essentially up to net zero ready, which we defined through the AIA 2030, Architecture 2030 standards, which AIA has also used in terms of efficiency for the energy use intensity for all of these buildings. And, it's about 10, 15 buildings a year. And in this case, by 2024, they get to about a 50% reduction in their CO2. And by 2030, they can get to enough of a reduction in their building loads that solar and renewable energy, which is shown in this upward curving blue line, can meet that. So once you have this data, once you have your buildings in there, once you have kind of an understanding of what the potential is of all these pieces, you can play with it. What happens if you don't get all your buildings to net zero? What happens if you take your biggest buildings first and then you follow with smaller buildings? What happens if you do all the rec centers at the same time, right? You can sort of play a lot of different games of accelerating or changing the parameters, and through that, really understand what your payback might be. But there's a lot of cost savings that benefits the taxpayers as well as the city, and pollution savings associated with this kind of zero over time approach. Two more projects I want to talk about. This one in India is really interesting, especially just because mobility ends up being, it was a surprising big impact for me when we were working on this. So this project, which, you'd think, wow, that's some kind of Corbusian nightmare, but it's actually a lot better than much of the infrastructure there. And it turns out people in India don't like commuting any more than the rest of us. And being stuck in the traffic in Mumbai is just something you don't want to have to do on a daily basis. So if you can get to a place where you can reduce the amount of commuting that you need to do, that's really great. This new development is about a 4,000 acre new city that's being built pretty close to Mumbai. It's almost kind of on the suburbs of it. And it's just being built out really rapidly. It's got 3 phases to it. The first phase is complete. We were focusing on the second phase, and the third phase is on its way. They own all this land. And so the focus of this was on the second phase. And in the second phase, we looked really at the urban design and how this can actually become a better, more transit-oriented, sort of low-impact development. And so a lot of these things are not particularly surprising. I think they're things we all know about, but what was surprising again to me was the impact. So, we made nice pedestrian walkways. We basically tried to reduce the amount of motorized transit. We had more electrification of vehicles. We just made it more convenient. And from a programming perspective, we tried to have as much work and residential work-live spaces as possible. So we kind of tried to make it a self-contained place to a large degree that didn't require leaving Palava. So this is showing kind of first overall kind of the amount of energy that's used, and this gray bar is the mobility, and we were able to reduce that mobility significantly. And then we're also reducing the energy used for commercial and residential buildings, added on-site generation, and we were still left with some other strategies that needed to be employed. But mobility is more than half, like 65% of the energy use and CO2 emissions. Well, 45% of the CO2 emissions. So here's the approaches that we took in terms of mobility. Increased walkability and bicycling, more kind of layout of the city that improves the non-motorized transit. Lots of electrification of vehicles, both the three-wheelers and two-wheelers, as well as the automobiles, providing charging infrastructure and so forth, providing better long-distance commuting into the city for those people that needed that. And we were able to predict leisure mobility coming down by 95% in terms of the amount of pollution, and that's a lot of it through electrification, and the commuting coming down by 86%, and a lot of that has to do with the work, live kind of work scenarios. So we reduced the amount of commuting that was required. Last idea here is this one in here in the US, Pittsburgh, Hazelwood Green. And Hazelwood Green is really kind of exciting. It's 180-acre former steel mill site, so brownfield site. And they wanted to do this development, mixed-use development, but they're really frightened about the first costs, and they're kind of concerned about making it affordable for Pittsburgh. Pittsburgh is not Denver. It's not a place that has skyrocketing real estate prices. So the economics are a lot different. So yeah, we were told it was unachievable. What we ended up doing was looking at a centralized kind of utility on this plant, on this site, that allowed us to share some of that infrastructure. And we'll talk about that integrated energy service provider. So this, basically the way that we did this, it's pretty straightforward. That's a typical building, and we added renewable energy. We had this district system of ground source heat pumps, and then we had building efficiency, and that gets us to our net zero approach. We looked at the building massing, and these two massing diagrams may look very similar, but by actually doing solar orientation and envelope kind of design, we were able to increase the insulation available, insolation, basically the sunlight available on rooftops and on southern facades by about 25%, while simultaneously increasing the density on the site. So this is to try and prove that idea that it really does make a difference from an urban design perspective, how you're kind of shading or not shading your buildings. That's something that, as designers, we can have a huge impact on. When we looked at all the different parcels on this site, there were some that never would ever be able to be net zero, tall buildings with small amounts of solar. And then there were some that would easily, overproduce parking garages and so forth. So, overall, when we looked at it, it looked like it would be possible to basically have an energy balance across the site. And what we did was we found places where, buildings produce more energy than they need, other areas that basically used more energy than they produced, and basically you move the energy around. So this is that sort of connection. And if there's even more energy than we need, that can also benefit the adjacent communities. So kind of understanding that from a thermal as well as a electrical perspective was key to making this cost effective. So this idea of the IESP, or Integrated Energy Service Provider, was key to making this cost effective. So the IESP acts as kind of almost a little utility on site, and they are able to basically get income through this all of these different services they provide: operations and maintenance, thermal energy, electricity, basically working with the grid and the utility. And they provide capital, and then they get these long-term returns. So it's not a huge amount of money, but it's very steady, and it's a good investment. So there's actually a lot of people interested in exactly this type of business proposition. What does it do? Well, here you have the cost of a typical building, and the cost of a net zero building is slightly more, but all of these pieces are kind of taken by the IESP, and they take that first cost essentially out of there, and they're financing that for us. So then we've got this reduced cost for the net zero energy building, and yet there's likely to be more valuable than a typical building. So the IESP gets those revenues back by basically, you know, getting the electricity bill and heating and cooling and on-bill loan repayment services. And those add up to less than a typical energy bill would be for a building occupant. So it's a clever way of trying to aggregate a lot of these different revenue streams that benefit both this IESP services provider as well as the occupants. So the conclusions there are, this is one way of kind of making the economics work in one of these sort of more connected communities with shared infrastructure and services. It's a technical path to getting to net zero energy. It reduces that first cost premium, which is oftentimes a deal killer. And it's a net savings for the occupants. So that should actually hopefully make these more viable in the community in terms of sales. And then overall, you know, it's doing what we need to do in terms of making the utility and the architecture work together in a complementary way. So it's a really kind of interesting way, and I think we need to continue to explore this kind of approach. So, architects, designers, this is our big opportunity, right? We can profitably create these NZE districts. It's pretty straightforward stuff I've been telling you. Insulate, make these buildings efficient, electrify them, add renewable energy, make sure you've got the transit-oriented development working for you. And then this kind of new piece, which is starting to think about connecting shared resources and coordinating across groups of buildings. And by doing this, we can start to help design this climate positive future. And these can be big, right? We need to, because as you know, this sort of next 10 years are critical for us to reach our climate goals. The time is now, and we have everything we need to do this, right? We have the technology, we have the knowledge, we even have the economics on our side, right? We can make money doing this. So that's typically been the thing that has stopped people. I think the last thing we need is the will to do it. And I actually think we have that now too. I really do think that there's a change in the weather where people really want to do this. And so this diagram comes from Architecture 2030. It's based on the International Energy Agency's work and the IPCC projections on climate. But this next 10 years, we have to turn the corner and aim towards zero emissions as soon as we can. It's a big job. And as a big job, we need to think about how we can do that. It's going to be bigger than anything we've ever seen before. But the solution is not going to present itself as simply as a big duck, even though we know the duck curve is important. And it's, you know, some people would say that's actually pretty cute. The solution is actually going to be many, many little ducks. It's a solution that requires portfolios of buildings, and each of our designs, each one of those ducks makes a difference. And together we can have this enormous impact that we need. Connecting our architectural design to climate can physically manifest the interdependence that we all have in creating a better world. So thank you, and I'm open for questions.
All right. Thanks, Victor. That was terrific. I guess my very limited takeaway there is don't duck your responsibility to environmental stewardship.
Thank you for making a worse pun than I did, because
I couldn't help myself. You set it up very well. So, and I do have some free intellectual property to give you. That chart that you had on the, it was on the integrated, the GEB curve. I think that's the Rolling Stone curve, or the Mick Jagger lips curve. It kind of reminds me of that. So maybe
Okay.
get some more interest generated outside of the usual suspects. So some of the questions we had from our attendees, and I think you may have started to come around to this when you were talking at the end about the integrated energy service providers. Ignacio asked, what's the dependency of GEBs from utilities? Do publicly owned utilities make a difference?
It's a good question. I think, my experience is that publicly owned utilities are oftentimes more responsive to community needs. So if we look up at Fort Collins, for example, they instituted quite a few of these sort of grid responsive approaches to the Fort Zed, or zero energy district, that they created in Fort Collins. And they see the benefits, right? So they are oftentimes much more open to seeing how that can be to their advantage. I think other, privately owned utilities or publicly regulated ones like Xcel are starting to see that, but right now it's a really it's a wild world out there. I think all the utilities have different approaches to this, and a lot of them see it as a threat. Frankly, they don't see necessarily that there's the same benefit financially as they might have through their kind of normal way of doing business. But I think the more progressive utilities, be they public or private or community owned, do start to understand that this is kind of the way the wind is blowing.
Mm-hmm. Yeah. Another question. We've got two questions about carbon. The first from Adam is on embodied carbon. And could you say a few words about how that correlates to today's presentation?
Yeah, so embodied carbon, I had a bunch of slides about embodied carbon that I didn't put in here, but it does make a huge difference. It's clearly right now something that we need to be focusing on, as well as the operation of buildings. This is really what I've been discussing is the operations. But essentially, when you are building a building, you're investing in carbon, right? You're basically taking a carbon loan out to build that building, how much you need to invest in it. And from that, you can try and get a return, essentially. So you should invest your carbon money in something that gives you carbon savings eventually. And that can be either through increased amounts of renewable energy. Sometimes we can actually use some projects or products that are carbon sequestering. I think Interface now makes a carpet tile, which has more carbon in it than it requires to make it. So it's a carbon negative carpet tile. And similarly, there's various other products. Cellulose insulation oftentimes is carbon negative. In terms of a community, one thing that you can think about is that there's always going to, just like with the operating energy of a community, there's going to be some buildings that create more energy than they use, and some buildings that use more energy than they create. And I think you can take that same netting approach to embodied carbon. And in case you have buildings which basically are high carbon to construct, you might actually balance those with carbon sequestering buildings to come up with a net carbon approach. Yeah, since not all of them are going to be able to be net zero in terms of their carbon sequestering abilities.
Right, and that gets to this additional question on the other side of carbon, which is on the emissions and output side. How do you anticipate future carbon emissions as you plan for the year 2030? Does that factor into grid evolution or climate projections?
Yeah, it's actually it's a really great question, and it's one that is very topical because the grid is getting cleaner, right? And it's not getting cleaner evenly across the United States or Canada or the world. It's getting cleaner unevenly and at different times. I would say in general, that's the trend. It's not going to probably get dirtier. There may be some places that it gets a little bit dirtier, but I'd say for the most part, electrification plays really strongly into that, in that we, from an architectural building operations perspective, we probably want to continue to depend on electricity for the most part and eliminate as much combustion on site as possible. And then the question about how we operate our buildings to, with that watt time kind of idea of, there's certain times you can buy electricity that's going to be better than others. Well, even in the future, if the grid gets a lot cleaner, that ability to modulate your building, the flexibility in its operation, is going to benefit you from a resilience perspective and from a cost perspective. If it turns out that the grid is 100% green, okay, maybe it's not going to change your pollution at that point, but it's still going to benefit you in several other ways.
Mm-hmm. Yeah, great point. And thanks, Kylene, for that question. Jennifer asks, what strategies or case studies can architects use for this high level of investment in projects when we may be joining the team, late to the game? Some of the decisions have already been made. I think about that massing study that you looked at. That was probably done before they asked an architect to give a look at the net zero energy goals for that project. And they said, well, wait a minute, your first design is going to get in the way.
Yeah, well, this is my life you're talking about, coming late to the table. And I think that a lot of times, for example, that massing study, they were pretty much done with the master planning of that community when we came in and we said, well, let's just take a look at that and see if we can improve it. So they were a little reluctant, but they were actually pretty proud of themselves when they found out that they could get 25% more solar on top. So I think that showing that you can basically bring money to the table or improvements to the design from a human experience level, from a energy performance level, is pretty much welcome. It is, of course, easier when you're there at the table at the beginning, but one of the pivotal kind of epiphanies in my practice was I was asked to go down to Texas and work on a police station. This was about 15 years ago. And they said, we're basically in construction documents and we want the minimum amount of LEED certification for the minimum cost. Yeah. And I was like, I don't want to do this, right? But it turns out the police station was, it was easy to fix some things. We changed a window spec, we changed some of the lighting specs, a little bit tweaking on the mechanical, and we were able to save 40% on the energy. And since it's a 24/7 building, it was an incredible difference. So I would encourage everybody to not be disheartened by coming into a project late or by being, the mere kind of energy concern in a large group of, financial people and engineers and architects. Make your voice heard. You will make a difference. Even if it's a small difference, it all helps. And oftentimes you don't even know how big a difference you're making until years later. So go for it.
Yeah. So earlier is obviously better than later, but better late than never, right? There's always
Absolutely.
something that can be done and given a second look with the architect's point of view. This is also embedded in that question, and I'm going to rephrase it a little bit. Who have been the drivers of some of these more higher impact, larger than single project district scale things? When you talked about Arizona State University, for example, you got a big institution and a president who's just crazy. I mean, he's got so many ambitious goals that he can put it out there and say, we're going to do this. He can put a moonshot out there. Is it those institutional leaders at scale? Is it utilities? Is it developers? Who's driving these goals, and who are the skeptics that you have to convince to get on board?
Yeah. Well, I do encounter a lot of skeptics, but typically we end up working with people that are already interested in doing this sort of thing. And one of our kind of tenets at Rocky Mountain Institute is that it has to make economic sense, right? Mm-hmm. So we always try and show that there's a bottom line dollar there. And that usually gets people over the hump. And then at that point, it's a matter of how far do you want to go beyond that. But for sure, there's people that are institutional leaders that are visionaries, and that really helps a lot sometimes. But we've had, stakeholders from every perspective. People, the utilities have come to us and asked for help, individual developers, and sometimes it's even a groundswell of kind of community interest in these sorts of things. So it comes from all sides, and I think everybody's got a vested interest in kind of these high performance projects.
Yeah. Well, we are right at the hour, and we could talk about this probably for the whole afternoon if we wanted to. I want to get to one more question, and then we'll wrap up. So this last question says, it seems to me that a lot of this requires high upfront costs, and you said in your takeaway that that's often a deal breaker, but the investment pays off in the long term. How do you convince investors and developers to put the first cost forward, especially knowing that this is technology we need to invest in?
So it depends on the interests of the people that you're working with. So sometimes people already have longer term holds, like if it's a municipality, the city is going to hold on to the buildings, or a college campus typically is, those, what they call the mush market, municipal, universities and so forth. But for other folks, it's tougher. And so some of that zero over time stuff we did with developers that had, 4 or 5 year hold times or 3 year hold times. And a lot of times we need to look, you kind of have to sharpen your pencils a little bit and just try and make the economics work. And we actually did work with REI, the outdoor equipment manufacturer, on their portfolio of retail stores. And we found an enormous amount of energy savings and cost savings over their portfolio of 150 stores with that kind of very short-term payback. The one other thing I would say is that oftentimes we will look at the payback of something like lights with windows, and therefore, the windows would normally have a 17-year payback, but when combined with something that has a fast payback, the overall payback may be satisfactory to the developer. So thinking about that integrated design approach to costs and energy oftentimes can get you over the hump too.
Yeah, design decisions often don't have a lot to do with the inputs of the building itself. It's just in how it is arranged. So that speaks to that. If you're involved early, you can make some of those key decisions. But it's also the fact that the input costs are increasing too, as more of manufacturing comes to scale and more innovations take place, and how to eke more watts out of every appliance, and how to get more energy collected through all the renewable sources. So it's not a totally uphill battle. There are some things that are on the designer's side and on the client side to help these things pencil out.
Mm-hmm. And there's value streams beyond money too that people need to take into account. People like green buildings, they like comfort, they like fresh air. Those things can turn into decision-making differences.
Yeah. Well, Victor, thanks so much. We're just enormously blessed to have the Rocky Mountain Institute here in our backyard as not just a national, but global leader in advancing these issues. And of course, we appreciate your work there for the Rocky Mountain Institute and all you do to give back to the profession. Appreciate that very much. And anytime we can continue the conversation, we'll look forward to that. Next week, I want to point out that on Wednesday, not our usual time in the afternoon, we're going to be convening at 4 o'clock. We're going to give a preview of everything the board has been working on to reset our mission and vision for the organization and all of us as a profession in Colorado to be leaders in the nation. And one of the imperatives that we have settled on, and hopefully the membership will get behind, is environmental stewardship. So you'll hear more about the variety of ways that a profession of architects and a community of design professionals can help make that move the needle on things like environmental stewardship. So I encourage you to participate in that and to watch our calendar for additional learning opportunities in the future. Again, a reminder today, you'll get 1 HSW credit for attending, and we will see you in the next space where we converse again. So thanks again, Victor, and everybody have a great rest of the week. Take care.
Bye-bye.